In this video, we're going to try to calculate out some information about two very low solubility salts. So some salts are incredibly low solubility, to the point that we basically don't consider them soluble, but there is still just an equilibrium of a couple ions breaking free and floating around. And so in this case, we've got mercury 2 sulfide and copper 2 sulfide. Our first question: find the number of mercury sulfides dissolved in 1 liter of water at equilibrium. And our second question: find the cubic kilometers of water needed to get 1 mole of copper 2 sulfate to dissolve. Go ahead and try these both, then unpause and come on back. All right, if you're back, let's start with our mercury sulfide. So HGS. Our KSP says that 2 times 10 to the minus 50 must equal, well, the ion separated. So that's going to be our mercury 2 plus and our sulfide 2 minus. There's one of each in the original formula, so we'll get one of each when they dissolve. So they're the first power. Well, whatever amount of one dissolves will get the amount of the other, so these must both be X. Some amount will successfully dissolve. So 2 times 10 to the minus 50 must equal X squared. So X for our mercury sulfide must be 1.4142 times 10 to the minus 25. That's going to be our concentration. So there's that many moles in our liter of solution. So 1.4142 times 10 to the minus 25 molar. Well, we want to know the number of these that would dissolve per liter. How many mercury sulfides successfully dissolve? So I have my number. So there's 1.4142 times 10 to the negative 25 moles of them in 1 liter. Well, we can turn our moles. We can say, hey, for every 1 mole, there's going to be 6.022 times 10 to the 23 of them. And so I can get out of the mole just into individual numbers. How many of the actual molecule is dissolved? Not just moles, but straight up counts of the number. 0.08516 for every 1 liter. So less than one of these molecules per liter will dissolve. In fact, roughly about an 8.5% chance for 1 HGS to dissolve. At any given moment, the chances that there's not even a single ion pair of mercury sulfide that has successfully dissolved into the water. Mercury sulfide is incredibly insoluble, so much so that there's plenty of it around. We actually find all over. It's a nice, beautiful red rock called cinnabar, because once it forms, it never goes away. It doesn't dissolve or anything, can break into smaller pieces, but it's never going to dissolve and run off. So it tends to get left as other things dissolve over time, though it can get weathered. Cinnabar is this beautiful red rock. It's actually probably where we got quicksilver first in the old days. You'd build a fire around a campsite. You'd use these nice brick red rocks around it as well that you found, and the fire would smell because the oxygen burns the sulfur away and leaves mercury behind. And so after the fire is done in the morning, you go and you notice there's this silvery liquid in your fire pit, and one of the rocks has burned away. So mercury sulfide, interesting compound, incredibly low solubility. Our second question: what volume in kilometers cubed do we need to dissolve 1 mole of copper sulfide? Well, the KSP was equal to 8 times 10 to the negative 34. They break 1 to 1, so that must equal our copper concentration and our sulfide concentration. First power for both of them, there's one of each in the formula, so this is going to be X squared again. X for each of the concentrations, so that's X times X. 8 times 10 to the negative 34 must equal X squared. Take the square root, and X is going to equal 2.828 times 10 to the minus 17. So very low concentration as well. 10 to the minus 17 molar is what the ions will be. And if we were in 1 liter, it'd be that many moles. But we don't want 1 liter, we want 1 mole. What we know is that this would be the concentration, how many moles per liter. So 2.828 times 10 to the minus 17 mole in 1 liter. Well, this has to be true for whatever ratio, whatever volume we go up to. If we double our volume, we'll double our moles. If we quadruple our moles, we'll need 4 times the volume. And if we go all the way up to 1 mole, what volume will we need? Well, we can rearrange the ratio. In order to solve what volume would I need to get 1 mole to dissolve if this is the number of moles in a single liter. Rearrange, solve for x. We'll find 3.5355 times 10 to the 16 liters is required. Well, 10 to the 12 is a trillion. 10 to the 15 is a quadrillion. So we're at 35 quadrillion liters. Put that into some perspective. Remember, there's 1,000 liters in 1 meter cubed. There's going to be a billion meters cubed for every 1 kilometer cubed. 1,000 times 1,000 times 1,000 for the meters on each side to form the kilometer. And so we can turn that into kilometers cubed, and we'll find that it is 35,355 kilometers cubed. That is the volume of water in cubic kilometers that you would need to dissolve a single mole of copper sulfate. Put that in perspective, is about 1.385 times 10 to the 9 kilometers cubed on Earth in all the oceans. So 0.0026% of Earth's water, which means throughout the entirety of the world, you're only looking at a couple thousand moles of copper sulfate that would be dissolved, presuming it's the only thing in solution. These are incredibly insoluble salts. The barest traces will ever dissolve from these materials. And so some salts simply have unfathomably low solubilities, but it's not truly zero. Any ionic compound can dissociate some of its ions. And here we can see just how little that might be, but they're still not zero.